Hello everybody. Okay, so in this video, we are learning about impacts and collisions. So we're just looking at an intro to impact. So what is a impact? So an impact is where an object hits a wall or barrier or the ground, right? That is all that a impact is. So what does that mean? Literally, I have a ball. It falls to the ground, and then it boing bounces back up. And what we want to measure is we want to measure this bounciness. Okay, I want to know, okay, if it's falling at a certain velocity, what velocity will it rebound at? And that is where my coefficient of restitution comes in. So the coefficient of restitution is a measure of how bouncy a collision is between two objects. It tells us the fraction of the relative speed after impact compared to the relative speed before impact. Restitution is another word for bounciness, right? And we denote this coefficient with the letter E. So a important formula here is the coefficient of restitution formula here. So it's minus E equals new velocity over old velocity, which equals V over U. So how do we interpret the coefficient of restitution? So if my coefficient of restitution is 1, my impact or collision is perfectly elastic. So no kinetic energy is lost. If it's between 0 and 1, it's partially elastic. So some energy is lost. And then if my coefficient of restitution is 0, that means it's perfectly inelastic. So my collision, they just stop or like stick together. So let's have a look here at a little simulator. So let me just get this ball like over here. So I have an object here going at 1 meter per second. So my coefficient of restitution, right? It's going to be 100%. It's going to be 1, right? It's going to be a perfectly elastic collision. So what that means is now my rebound speed should be equal to 1. So let's have a look here. Boom. And as we can see that, my ball comes back with a speed of 1. Now, if we're kind of talking in terms of velocities, right? So this is going 1 in the I direction. So my velocity is just 1, so 1I. Then if I let it go here, bung, it becomes minus 1. So minus 1 over 1 is equal to minus 1, which is my coefficient of restitution. So what if my coefficient of restitution was like 0.75? That means, right, my rebound speed should be 0.75 meters per second. So let's have a look. And it is here, so it's going a bit slower. Then when it hits off this wall, it should decrease again, another 0.75. Right. Now, if it's perfectly inelastic, my coefficient of restitution is 0, it should just stick to the wall. That's it. It loses all of its kinetic energy. How fun. So, let's have a look at the question here. A ball hits the ground vertically with a speed of 10 meters per second and rebounds upwards with a speed of 6 meters per second. Find the coefficient of restitution E between the ball and the ground. So I have a ball. Can I turn auto shapes on? That makes things a little easier. No. Okay. Right. So a ball hits the ground vertically with a speed of 10 meters per second and it rebounds vertically upwards with a speed of 6 meters per second. What is the coefficient of restitution? So I have a ball. It's going down with a speed of 10 meters per second. So now I'm kind of dealing with velocities here. So it's going to be minus 10 meters per second over. And then it's going to bounce up. At a speed of 6 meters per second. So minus E is equal to V over U. So minus E is equal to 6 over minus 10. Minus E is going to be equal to minus 0.6. E is equal to 0.6. So my coefficient of restitution for this is 0.6. Let's have a look at one more example here. So a ball falls vertically from a height of 2 meters onto a horizontal floor. The coefficient of restitution between the ball and the floor is 0.9. Find the speed in which the ball hits the floor. So this is going to be a linear motion question. So I have a ball here. It's going down. Its starting speed is 0 because it falls, right, from rest. V is what we're trying to calculate. The acceleration, well, it's falling vertically, so my acceleration is just going to be gravity, G, and my displacement is equal to 2 meters. So V squared equals U squared plus 2AS. V squared is equal to 2G times 2. V squared is equal to 4G. V is equal to the square root of 4G, which is equal to 6.92 meters per second. Yeah, actually no, 6.26 is it? Wait, 4 times 9.8, try with that, ding, ding, ding. Do apologize, 6.26 meters per second. So the ball is hitting with a speed of 6.26 meters per second. Find the speed of the ball after the first bounce. So I have my ball. Now, it was going down with a speed of 6.26 meters per second, but we're dealing with velocities here, so it's minus 6.26 meters per second. Then it hits off the ground. Then it bounces back up. We don't know what the speed is, but I do know my coefficient of restitution is 0.9. So minus 0.9 is equal to V over minus 6.26. So it's going to be my speed after, I'm basically retaining 90% of my speed or my velocity. So it's going to be 5.63 meters per second. And that's my answer there. Then find the height at which the ball then rises. So now, kind of like a projectiles question. I have my ball here. It is now rising with a speed of 5.63. Okay, so its initial speed or velocity is 5.63 meters per second. Right, I want to find how high it rises. So it reaches its max height when its final velocity is 0. The acceleration was working against gravity, so it's going to be minus G. And then S is what we're looking to find. So V squared equals U squared plus 2AS. V squared is 0. u squared, so 5.63 squared minus 2gs. So 5.63 squared minus 31.6969 is equal to minus 2gs. So divide both sides by minus 2g. Then I'm left with s is equal to S is equal to 1.617 meters. So my ball then rises at 1.617 meters. Right, so that's the intro to impacts. I hope this video was some help to you guys, and I'll catch you guys later. Bye.